Now that we've got a good handle on all the different techniques of factoring, in this section we want to go ahead and we want to see, if I just give you a factoring problem, which method am I going to apply? So we're going to try to look for clues and get some more practice with that. So we're going to just start with what is our general approach to factoring. So first and foremost, before you do anything, you want to first look at every single term and see if there's a common factor. If there is, take that out because it's going to make your life way easier and give you less possibilities for what to factor. From there, you want to look at the number of terms, and that's basically going to help you figure out, am I applying one of my general techniques of guess and check? Is it a special formula, or am I going to be doing grouping? So if you just have two terms, you want to see if they're perfect squares because it could be something minus something. And then you're going to go ahead and try your guess and check using those squares terms. If you have three terms, then you want to go ahead and check if the first and last terms are perfect squares and try that in your setup in the guessing. If it works, great. If not, then you go on and try something else. If there's four terms, then you want to go ahead and see, can I do factoring by grouping? So group the first two together, group the second two together, and then see, do those groupings have something in common? After you've tried those techniques, then you want to look at the individual pieces and see, oh, did I miss anything? Can I factor something out? And do that. And then the last step is more so, if you have time, it's a good habit to get into, you want to check by multiplying. But in these cases that you're doing that guess and check method, where you're making the first terms match up, the last terms match up, you don't need to go through full foiling. Instead, what you can do is just check, do the outer and inner, give me the correct middle term. So really, we just have a ton of examples, and we want to try to look at a problem and we want to see, okay, what technique do I use? So if I look at this first example, if I look at my first numbers on each of those, I only have two terms, and the 64 and the 9 are perfect squares. So what I want to do is I want to set this up, and I want to try my guess and check method. My first two things have to multiply to 64m squared. So I'm going to try 8m and 8m. And then my last two terms need to multiply to negative 9p squared. So let's try a negative 3p and a positive 3p. So the first and last terms are good. Now we go ahead and check the outer. That gives us positive 24p. The inner gives us negative 24mp. And the inner gives us exactly the same thing. So when we add those up, they cancel each other out. And so this is our correct factoring. Okay. In this next example, we've got 32x squared, 8x cubed, and then 24x to the fourth. So right off the bat, every single term has an x, so I can definitely take out that smallest amount. I'm going to take out 2, so it's going to leave me 1 in this term and 2 in this term. The other thing I notice is that these numbers out front all do share something in common. So they're all divisible by 2, they're also all divisible by 4, and they're also all divisible by 8. So really I can actually take out an 8 at most. So for this expression, our greatest common factor is going to be 8x to the second. So if we take that out, from the first piece to get to 32, we need 4. So 4 times 8 is 32. I've taken out the x squareds. From the middle term, I've taken out the 8. I take out 2 x's, so I'm left with a single x in return. From the last, we have that minus sign. If I take out the 8, 3 times 8 gives us 24. I take out 2 of the x's, so we're left with an x squared. And then from here, we have a trinomial that we have to factor. The problem is my x squared term is at the end and it's negative. So what I'm going to do is I'm going to also take out a minus sign to make the squared term positive. So what that does is it really changes every single sign. So it would be -4, -x, and positive 3x squared. And then I'm just going to rearrange this to put it into the order we're used to. The 3x squared first, the -x in the middle, and then the -4 at the end. So now we're at a point that we can go ahead and do our guess and check method. We need the first terms to multiply to 3x squared. So I'm going to go ahead and use 3x and x. And then we need the last terms to multiply to -4. So I'm going to try a -4 and a +1. And now we want to see, do the outer and inner give us this middle term? So if I look at my outer term, that's positive 3x. The inner is -4x when we multiply them. So those indeed add up to the -x in the middle. So we did find the right factoring on the first shot. And so this would be our fully factored form. And again, we can go ahead and we can multiply this out if we want, but to save ourselves some time, we're not going to. So we keep going. We're going to try now with 56k to the third minus 875. So looking at this right off the get-go, I have a k cubed. That tells me I'm probably going to use my cube formula. The problem is neither of these numbers are perfect cubes. And because they're not perfect cubes, I want to see, can I factor something out to get numbers in front that are? And so if you think of 56, because that's the smaller number we can work with, it's divisible by 7 and it's divisible by 8. If you go ahead and take 875 and divide it by 7, you'll also get another nice number. So both these numbers are divisible by 7, and if we take that out, we're left with 8k to the third minus 125. Okay. And by taking out this 7 now, I get numbers that are both perfect cubes. So the 8 is the same thing as 2 to the third, and 125 is 5 to the third. So we just leave our 7 out front, and then we go ahead and we set up our cube formula. So remember, we use SOAP to figure out the signs. We do the same sign, the opposite sign, and then the last one is always positive. Okay. In the front spot, I start by putting just 2k, the thing being cubed. And in the front spot here, we get 2k squared. And then in our last spots, it deals with the 5. So we just get a 5 and then 5 squared. And in the middle, we do the product of the two things that are being cubed. So 2k times 5. And then from here, just a tiny bit of cleanup. 2k squared would be 4k squared. 2 times 5 gives us 10. And 5 squared is 25. Okay. So that is our fully factored form. Right. Now in part D, I have 4 terms here, so that means I probably can't do any method that I'm used to. I look at all the terms, the k, q, and 9q only have a q in common. There's nothing in common to everything simultaneously. So since there's 4 terms, this is my good indication to do factoring by grouping. Because if I look at the first 2 terms, they share a q in common. And if I look at the second 2 terms, they share an r in common. So we're going to go ahead and we're going to group the first 2 pieces together. And then we're also going to group the second 2 pieces together. So from the first piece, we're going to take out a q, and that leaves us with k minus 9. From the second piece, we take out an r, and that also leaves us with k minus 9. So now I've got two terms and they each have k minus 9 in common. So we are able to factor that out. And from the first piece, it leaves us with q. From the second piece, it leaves us with a positive r. Okay. So just a couple more examples that we're going to try out. We've got 4k squared, 28kr, and then 49r squared. So if I look at all the terms, they're not really seemingly divisible by something because I don't have all even numbers. It's 49 throws things off a bit. But if I look at the first and last numbers, they are perfect squares. So this tells me let's try my guess and check method, and I'm going to try those perfect squares as my first guess. So to get to 4k squared, we need 2k and 2k. To get to 49r squared, we can do 7r and 7r. And then they're both the same sign. This is positive in the middle, so that tells me to put two positives here. Okay. So this is our educated guess as to what this foils. And if I go ahead and I check my outer term, that gives us 14kr. The inner term also does the same thing. We get 14kr. And if we add those together, it does indeed give us the 28kr in the middle. So it factors into the same term being multiplied twice. So really we can condense this and write this as 2k plus 7r to the second power. For this next one, if I look at those powers, I've got x cubed and I've got y cubed. So the only thing I can really do is use my perfect cube formula. 27 is a perfect cube, so that's good. But unfortunately, this 3 isn't. So looking at this, based on the fact that this is not a perfect cube, I need to see, can I take this 3 out? And then does it leave me with something that I can continue to factor from there? And so luckily, both of them are divisible by 3. We can take that out. That will leave us with 9x cubed minus y cubed. So now going on from here, this piece is good, but now the 9 is not a perfect cube either. So unfortunately, we're not going to be able to use our perfect cube formula. So at this point, we really can't factor anymore. Because that perfect cube formula only applies when that number out front is also a perfect cube. Okay. And now for our final example, we have 3 terms. So again, go into the guess and check method. I want to take a look at these 2 terms and see if they're perfect squares. They're not, so I'm not going to try that. This is just going to boil down to my guess and check method. So to get to 2m squared, I definitely need 2m in one spot and m in the other. To get to 15, I have a couple different ways. I have 5 and 3. One has to be positive, one has to be negative. So let's try to put the positive 5 here and the negative 3 here. And in doing so, if I look at my outer term, that gives us negative 6m. The inner term gives us positive 5m. If you add those together, it does give you the correct middle term. So this is the correct factoring. Okay. So factoring just takes a lot of practice to start recognizing these patterns and recognize tricks you can use. So do your best and get tons and tons and tons of practice.